In the first part of the lab, you're going to need a few items such as a round bottom flask, a condenser, a stir bar, as well as some tubing for the condenser, a clamp. You'll also need a heating mantle and hot plate, though we're only using the stir function on the hot plate. You'll also need anthracene 9-methanol, as well as our other reactant, N-methylmaleimide, which is toxic and corrosive, so you do want to clean up spills thoroughly. First, we're going to measure out our anthracene 9-methanol, and we need about 0.065 grams of this reactant. So I'm first going to zero a weigh boat on the balance, as usual, and then I'll add the anthracene 9-methanol. So here you can see that anthracene 9-methanol is a yellow powder, and I'm going to try to weigh as close to 0.065 grams as possible, but you can find the exact amount that I used in the lab data document on the lab assignment page. Now we're going to add the anthracene 9-methanol to our 100 milliliter round bottom flask. Additionally, we'll also add 50 milliliters of water. Some of the reactant was left on the weigh boat, and I tried to scrape as much as possible into the round bottom flask using a spatula, but I also rinsed the weigh boat with a little bit of my 50 milliliters of water. And then I'll continue to add the rest of the 50 milliliters of water from the graduated cylinder. Next, we need 3 equivalents of N-methylmaleimide. You will be asked in your post-lab report to calculate how many grams 3 equivalents is worth. So first, I'm going to zero the balance, or zero the weigh boat, and then I'm going to add the N-methylmaleimide. You can find the exact amount that I used in the lab data document on the lab assignment page. You can see that N-methylmaleimide is a white solid. Now I'm going to add the N-methylmaleimide to the round bottom flask. Next, we're going to reflux our mixture for 1 hour. So I have the stir setting on, which will stir the stir bar in the round bottom flask. I'm also going to heat the mixture, and then we have our condenser with water coming in from the bottom and out through the top to keep everything cool. After an hour of reflux, I removed the round bottom flask from the heating mantle, and now I'm going to test the reaction progress using a TLC plate. So I will get that set up next. There are a few items that we'll need to prepare for the TLC portion of our procedure. We're going to need some beakers labeled with the names of our reactants, and we're actually going to dissolve a little bit of each reactant with ethyl acetate mixed with hexane. So that will be our TLC solvent. So I'm just going to add a little bit of each reactant to the appropriate beaker and dissolve them. So here I have my reactant solutions that I can use on the TLC plate. As we've seen previously, you do need to make a line 1 centimeter up from the bottom of the TLC plate. That's where we're going to place our 2 reactants and our product, and then we'll compare them later on. So here I'm labeling the first dot as A9 for anthracene 9-methanol. I'm labeling the second dot as N-N M for N-methylmaleimide. And then the last dot on the right will be our product. Now I'm going to add each reactant and the product to the TLC plate using open-ended capillaries. They're quite small, so you do want to be careful when handling them. Now I'm first going to draw up some of the anthracene 9-methanol into the capillary, and then I'm going to place 2 to 3 dots or spots of the solution on the plate. Then I'm going to do the same thing for N-methylmaleimide, and again this is so I can compare the product to the reactants and see if I do indeed have the product or if I didn't reflux long enough. Finally, I'm going to add a small amount of the product solution to the last dot on the TLC plate. This can be a little bit tricky to get the capillary tube inside the round bottom flask, so sometimes it might be easier to use some tongs or tweezers. Next, we'll prepare the development chamber with a CHEM wipe. The CHEM wipe allows solvent to evaporate throughout the container, which helps the TLC plate to develop. I'm just measuring 0.5 centimeters from the bottom of the beaker. That's about how high our solvent layer should be. And again, I'm just adding some ethyl acetate mixed with hexane to the development chamber. And finally, we'll add the TLC plate to the chamber as well. Typically, we don't want the TLC plate to touch the CHEM wipe, but sometimes it's hard to avoid. So now I'm zooming in and I'm going to fast forward the video so that you can see the solvent rise up the TLC plate. Once the solvent has reached nearly the top of the TLC plate, I'm going to remove it from the development chamber, and then I'm going to draw a line across the top where the solvent has stopped. That way I can later measure how far the solvent moved. So you might have noticed that we didn't see anything moving up the TLC plate other than the solvent. So we do need to visualize it with a UV light. Now, my first TLC plate did not go as planned. I think the TLC plate might have been touching the CHEM wipe too closely. So I ended up running a second TLC plate, and on this one, the spots are much easier to see. Although it looks like I might have had a little oversaturation on the first spot, the anthracene 9-methanol. But there are still some very clear spots for the reactants and the product. So I will circle those and you can measure their distances. So here I've already circled the spots, and I've also set up a ruler next to the TLC plate. And you can find a picture of this on the Canvas lab assignment page. So after verifying through the TLC plate that we did form the product, then it was time to crystallize the product. So I'm going to place the solution into an ice bath. And actually you can already see some crystals forming just as it cooled down. So we'll place this in the ice bath for a few minutes and let the crystals form. While we're waiting for the crystals to form, we can set up our vacuum filtration system so that we can separate the crystals from any remaining liquid. So here I have an Erlenmeyer flask with a Buchner funnel, and that's connected to a separate Erlenmeyer flask through a tube. And then the second Erlenmeyer flask is connected to our vacuum line, which is in yellow. So we can control the vacuum line through the handle on the outside of the fume hood. Once I feel that there are enough crystals in the solution, I'm going to pour this into the Buchner funnel, which already has a piece of filter paper in it. And I'm going to aim towards the middle of the filter paper so that product doesn't fall along the outside edges down into the Erlenmeyer flask. So again, crystals will be collected in the Buchner funnel, and the liquid will fall through to the Erlenmeyer flask. And here are the crystals. So they are yellow in color, and there weren't a lot of crystals, but we'll weigh them and see how much we ended up with. So now I'm transferring the crystals into a pre-weighed weigh boat. You can find the mass of the empty weigh boat in the lab data document, as well as the mass of the crystals with the weigh boat. In the final step of the lab, we're going to weigh our crystals and see how many we have. You can find everything you need for the lab report on the lab assignment page on Canvas. Good luck!